Okay, so for C, I think I brought it over left off. They want vector AT, so they want us to get from here to there. How could we do it? Okay, well, to get this one, I really don't like this question. You kind of need to read the directions. The directions said the ratio of this to this is 1 to 2. So this is like twice as long. So vector AT basically is going to be 1/3 the length of vector AC. So we just take our answer from B and multiply it by 1/3. Because this answer on B was vector AC. That's how we got from there to there. We went like that. So we just take our answer to B and multiply by 1/3. All right. You know what? Let's skip D. I'm kind of done with this one. The homework lesson this one was kind of based on. Yeah, I didn't end up taking a score on this one.
Let's go.
Yeah, because that was the worst one we did this chapter. Okay, number 3, a plane is on a course of 320 degrees at a speed of 480 miles an hour. So where is 320 degrees at? Let's do the headings of the compass here. Northeast. So where was 0 degrees at? Let's start with that. Yeah, at the top. Because we're doing northeast, southwest, that's 0 degrees. So 320 would be 40 degrees short of 360, right? So it's 40 degrees short of a full rotation. So it'd be up, up there somewhere. That would be the heading. And it says we're going 480 miles an hour. That would be like the, even though it's a speed, that would be the magnitude of the vector. So many texts. They're not important. What are the north, east, and southeast? So, north, south, and east, west components, and the velocity. Oh, it's velocity vector. Okay. So, in other words, how far is this vector moving west, and how far is this vector moving north? So, the west component would be like the x value basically, and the y component, the north component would be like the y value. So how could I find out how long this is right here? Start with that. Okay, we need an angle because basically we got a right triangle, so we're using SOHCAHTOA, right? We're using that trig stuff. If this is 40 degrees right here, what must this angle be right here? 50. How did he know it was 50? These two together make 90 degrees, right? So we got a 50 degree angle, we got 480, so that's enough. We can use SOHCAHTOA. Relative to this angle, x is the what side? Adjacent. 480 is the hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So right? So cosine of 50 equals adjacent over hypotenuse. So cosine of 50 times 480. What'd you get, Owen? Say again. 308.5. Okay, they probably wrote 308.5 miles per hour west. Let's see how they did write that. Yeah, that's exactly what they wrote. 308.5 miles per hour west. And, okay, so for the north direction, relative to this angle, we're looking for the opposite. We have the hypotenuse. Which trig function would that be? Sine. So sine of 50 equals opposite over hypotenuse. So kind of the same thing, but sine. Sine of 50 times 480. My picture wasn't very accurate. This line should have been more like that. Kind of screwed my picture up a little bit, but not a big deal. Okay, number 4. Given the points A, B, C, D, find the coordinates of dx, y, such that A, B, C, D is parallelogram. Alright, I'm going to draw, you don't really need a graph for this. I'm going to kind of draw a fake picture here. A is 1, 3, B is 0, -3. Okay. The picture doesn't really matter, but it kind of will help us visualize what's going on. I'm kind of just making this up here. A, B, C is 5, 0. Okay, and they ask for the coordinates of D. Okay, what we know is that this is supposed to be a parallelogram. So it might be, you know, a little more like this, like slanted, but it doesn't really matter. Okay, how could we find the coordinates of D? Okay, well, if we think about this vector right here, whatever this vector is matches this vector, right? They're going the same direction, they're the same length. So if we figure out how to move from B to A, that will be the same as how we move from C to D. So what's vector BA? What's the component there, Shelby? Taking pictures. Yeah, in the x direction, the x component, how far are we moving? From 0 to 1? 1. In the y component, from -3 to 3? 6. Okay, so this vector gets us from B to A. That should be the same vector that moves us from C to D. So we're just going to add 1, 6, and we would get the point 5 plus 1, 0 plus 6. So the answer is 6, 6. Most of these questions, there will be like one like this on the test. Number 2 is not on the test. That's kind of why I skipped it a little bit. Not a big fan of that one. Okay, number 5. Find the velocity and speed of an object that moves with constant velocity so that its position at time t is xy. Let me copy this down. xy, -2, -2, plus t1, 4. Find the velocity and speed of the The velocity, do you guys remember these vector equations, and then right after them we'd write like a parametric equation, that assignment? Oh, I'll remind you, it's okay. The velocity is basically this thing. T kind of stands for time, and every like 1 second, 1 minute, whatever T is, it's going to move right 1, up 4. And we kind of graphed this on this assignment, and it looked kind of like that when I graphed it. -2, -2 is basically the starting point, but 1, 4 kind of tells you how it moves. Every time T goes up by 1, this moves another 1 right, 4 up. So this is what they call the velocity. So for the first part, it's 1, 4. Oh, and then the magnitude. So what would the magnitude of 1, 4 be? Do you guys remember how we found this? Right, basically it's Pythagorean theorem. We just did 1 squared plus 4 squared, and then we did like the square root of that. Doesn't come out very nice. 16 plus 1, square root of 17. You just leave it like that. Okay, B says find a pair of parametric equations. So that's when we split it up. These were, you guys pretty much got all these right, if you remember what it meant. It's when we split up the equation into an x and a y component. So for the x component, how is it moving? It's starting at -2, and it's increasing by 1 t. So -2 plus 1 t. And then how is the y component moving? It's starting at -2 and it's increasing by 4t. 4 times t. Mrs. Plummer had a name tag on. I guess it's because she's a grandparent, maybe? Question mark?
Yeah. It's just normal.
Okay. Oh, is there another question? Where in this problem? Yeah, I don't know about that. Yeah, okay. I don't care about 6 either. Let's look at number 7. Okay, 7 had a formula to go with it. It is not on the board right now. I will be giving this to you on the test. You don't have to memorize this, you just have to know how to use it. Let's see, what was it? Mag u dot v. Oh, shoot. Okay, before we do this, let's remember, what does u dot v mean? So these are vectors. What does it mean when you put a dot right there? Let's do an example. Yeah, it's called dot product, yes. So if you do the dot product of two vectors, you basically do the x times the x plus the y times the y. So this one would be -3 times 5 plus 4 times 1. So -15 plus 4, -1. That's the dot product. It's used for this kind of problem where you're looking for the angle. Okay, what did these symbols right here mean? Magnitude. So the top means the dot product, the bottom means the magnitudes multiplied together. And then to find theta, the angle we're looking for, we're going to have to do cosine inverse of all this jazz. But before we do that, okay, I'm going to copy these down. A is 1, 3, B is -2. A is 1, 3. kind of like before, I'm not really worried about making a good picture. The picture is not the point here. Did I copy that right? B is -2, 7. I got that backwards. Okay, and then C is 0, -6. Find measure of angle A. Forgot already. 0, -6. Okay. All right, so what we need first, the U and the V stand for vectors. So we need the vectors that would create angle A. We need these two vectors right here. So starting with vector AC, if we're moving from 1 to 0, how far are we moving in the x direction? -1. For the y component, we're moving from 3 to -6. That's -9. If you're not sure, you kind of subtract backwards. You do -6 minus 3. So it's moving -9. We're going from 3 to -6, that's dropping 9. So vector AC is 1, -9. -1, -9. Okay, that'll be one of our vectors. And then we need vector AB also. Now they told me we're looking for angle A, so I need the vectors that kind of create that angle. I need both these. So for vector AB, going from here to here, we're going from 1 to -2. How far is that moving in the x direction? -3. The y value, 3 to 7. Or you could say, what's 7 minus 3? +4. So vector AB equals -3, 4. Okay, so you got to get those vectors, and then you start plugging them into our little formula up here. We're looking for the angle, that would be the theta in this formula. Okay, so the first thing is the dot product. So we got to do the dot product of these two, so that'd be -1 times -3 plus -9 times 4 over the magnitude multiply. How do I find the magnitude of a vector? It's basically quadratic formula. 1 squared plus 9 squared, square root of that. 81 plus 1, you like square root of 82. You don't really need to these might simplify sometimes. It doesn't really matter though. It's not the answer, it's just something we need in the formula. So you guys might know this. If we have a 3, 4, what's this magnitude going to be? 5. Yeah, that's right. So you could do 3 squared plus 4 squared. It'd be 25. Square root of 25 is 5. Okay, anyway, cosine of theta equals all that. So to find our theta, what do we need to plug in the calculator? Cosine inverse. I'm going to simplify this a little bit. Up here, this is 3 plus -36. So that's like -33. The bottom, I don't think we really need this. That doesn't simplify. Or even if it did, you wouldn't have to. But that's what I would plug in the calculator. All right, what do you get, Willow?
136.
Perfect. Yes, it is that. Okay. This will be one of the harder questions on the test, just because there are so many steps. The formula will be given to you, but just like remembering that you have to find the vectors in the first place. Okay, that's something you have to do. And then knowing how to plug the vectors in. How do you find the dot product? How do you find the magnitude? All that. There's just a lot of steps. So it's kind of, it'll be graded kind of like an essay The more you do right, the more you get. This is probably the hardest one we'll do though. Okay, number 8. These formulas on 8 I am not giving to you. One of them is the distance and the other is the midpoint. Okay, this will also be on the test. Do you guys recall what was the distance formula? When you're talking about like 2 points on a graph, how did we find the distance between those 2 points?
Square root of x minus x squared plus minus y squared plus z minus.
Okay, yeah. The difference in this chapter was we did 3 dimensions. Whoops. So there was a z component. So we had to, yeah, that's what Grant just said. Z minus z squared is included. So it's kind of adding on to something we've done in the past. This is a 3-dimensional vector or whatever we're finding the length of. Okay, and then there was a midpoint formula. Do you guys remember this one?
X plus x over 2. Yeah, just all that.
Okay, yeah. There's, to find the x coordinate, you average the x coordinates, y coordinate, and now there's the new improved, there's a z coordinate. Okay, I don't think you guys will have too much trouble with this. You're kind of used to these formulas. In fact, why don't you guys try and plug these in on your own, and I'll give you a couple minutes so you can figure it out. We're doing number 8, so you just have to look at it. After this, Eli, you should probably, and Grant, question mark? Eli and Grant, you guys should probably go. You guys get it sorted? Tell me what you got, we'll see if you guys agree.
Like 2 squared root of 262 for the distance. And then
Negative 1, negative 1,
yeah.
Say again, I didn't hear you.
2 squared root of 62, and then negative 1, and then positive 1.
-1, -1. Okay. Anybody else get, yeah, that's what the book says. Alright.
Thank you.
By Eli. Whoa.
And then there were 4. Do we want to keep going? We're close, but there's just not many people here.
Oh, it's been a long week.
You haven't even been here.
We hardly got anything
How
done.
many days have you been here? 1. Today? No, it's our month.